All right, let's fire this thing up. We're diving deep into the world of heating today, and I know you're particularly interested in rocket stoves.
Rocket stoves are pretty fascinating, aren't they?
Yeah. So, for this deep dive, we're taking a bit of a different approach. We're actually going to be looking at a conversation between a user and ChatGPT.
Well, that's interesting, using an AI chatbot as a source.
Exactly. It gets pretty wild, covering everything from those efficient rocket stoves to the classic Viadris wood-burning boiler, you know the one.
Oh yeah, the Viadris, a real workhorse.
For sure. And they even go into some pretty out there ideas like burning used oil and even harnessing the power of plasma.
Plasma for heating. Now that's thinking outside the box.
I know, right? So let's start with the basics. What makes a rocket stove so, well, rockety?
Well, it's more than just a catchy name.
Hmm.
It's all about the way it burns incredibly efficient and powerful.
Okay, so it's all about efficiency. But
Mhm.
how does it actually work?
It's like this. The heart of a rocket stove is its insulated combustion chamber.
Insulated combustion chamber.
Yeah. And that chamber gets incredibly hot, which creates this chain reaction of efficiency.
Okay, I'm intrigued. Tell me more.
So first, that intense heat creates this powerful draft, almost like a natural turbocharger.
So it's like pulling in air and feeding the flames, making it burn even hotter.
Exactly. And then, here's the really cool part. Rocket stoves use something called secondary combustion.
Secondary combustion.
It means that the smoke, which normally just carries away a lot of heat, gets a second chance to burn.
Hold on, you're saying it burns the smoke.
Yep. The gases from that initial burn are channeled into another hot zone where they ignite. It releases even more heat.
Wow. So it's not just burning the wood efficiently, it's also burning the smoke. That's brilliant.
It's a pretty ingenious design.
It is. No wonder they're known for being so efficient.
Yeah, they're like the physics-obsessed engineers of the wood-burning world.
Uh-huh. I love that. Now, speaking of efficiency, you mentioned the Viadris wood-burning boiler. I actually have one myself.
Oh, you do? How do you like it?
It's a beast. Simple, reliable, and can handle those big logs for long burns. I've even added more fire brick and started using the top-down burning method.
Oh, nice. I've heard those upgrades can really improve the efficiency.
Yeah, I was thinking it might even get close to rocket stove efficiency.
Well, those upgrades definitely help. The firebrick acts like a heat bank, and top-down burning creates a more even and complete burn.
So it's better, but still not quite a rocket stove.
Right. It still lacks those core elements of a rocket stove, that insulated chamber, and the dedicated secondary combustion system.
Okay, so my Viagress might be a more sophisticated worker now, but it's still not a finely tuned machine like a rocket stove.
Exactly. But hey, sometimes a reliable workhorse is all you need.
True enough. Now, I'm really curious about those more unconventional ideas we talked about earlier, like burning used oil for heat. That seems pretty wild.
It does, doesn't it?
Wow.
But remember how we talked about rocket stoves squeezing every bit of energy out of fuel? Well, burning used oil efficiently relies on those same principles.
So we're talking about precise control over combustion and maximizing heat transfer.
You got it. And there's something kind of poetic about turning something we consider waste into a powerful heat source.
It's like alchemy, turning trash into treasure.
Exactly.
But how does burning used oil actually compare to burning wood in terms of efficiency?
Well, used oil actually has a higher energy density than wood. You get more heat per unit of fuel.
Wow, okay. So it's potentially even more efficient than wood, but I imagine it's trickier to burn cleanly.
It can be. The key is to burn it efficiently and cleanly, and that's where those rocket-like principles come in.
Right, like controlling the burn.
Exactly. You need to preheat the oil to a point where it vaporizes before it actually combusts.
It sounds like you need a pretty specialized setup for that.
You do, but it's worth it if you're looking for a sustainable and efficient way to heat your home.
I can see the appeal. All right, so we've covered rocket stoves, the classic Viadris, and even touched on burning used oil. What about that plasma heating idea? That sounded straight out of a sci-fi movie.
It does, doesn't it? But the potential of plasma for heating and even generating electricity is very real.
Okay, I'm all ears. What is plasma and how could we possibly use it to heat our homes?
Well, think of plasma as superheated matter. It's so hot that the atoms have broken down into charged particles.
So it's like harnessing the power of a mini lightning bolt.
Exactly. And to create that plasma, you need to apply a high voltage across a gas, like air.
And that creates an electrical arc.
Exactly. Similar to what you see in a welding torch or a plasma cutter.
Okay, I'm starting to get the picture. But how do we use that arc for heating?
Well, the ChatGPT conversation talked about modifying a plasma cutter to create a continuous plasma arc, and then using that arc to ignite and sustain the combustion of a fuel source, like used oil.
Wait, so we're taking a tool designed to cut metal and turning it into a heating system?
It sounds crazy, right?
Yeah.
But it highlights the incredible power and versatility of plasma.
That's mind-blowing. So instead of a traditional boiler, we're using a plasma arc to superheat the fuel.
Exactly. And because plasma can reach these insanely high temperatures, thousands of degrees Celsius, it can potentially burn pretty much anything, even stuff that's difficult to burn with conventional methods.
Wow. So it's not just about efficiency, it's also about fuel flexibility. But I imagine there are some safety concerns with something that powerful.
Oh, absolutely. Working with plasma requires careful consideration of safety and engineering challenges. We're talking extreme temperatures and high voltages, so proper containment, shielding, and control systems are critical.
Makes sense. So while it's a fascinating concept, it sounds like it requires a serious level of expertise.
It does. But the potential benefits are enormous,
Mhm.
especially in terms of efficiency, fuel flexibility, and waste reduction.
Okay, I can definitely see why it's worth exploring further.
It is. And the fact that we're even having this conversation is a testament to how AI, like ChatGPT, can push the boundaries of what we think is possible.
It's pretty amazing.
It is.
All right, well, we've covered some pretty wild ideas so far, but I want to bring it back down to earth for a bit.
Sounds good. What are you thinking?
I'm still really intrigued by that idea of burning used oil for heat. It seems like a more practical and potentially sustainable option that I could actually implement.
It's definitely a viable option, especially if you have a reliable source of used oil.
Yeah, that's a good point. So, what are the key things I need to know about setting up a used oil heating system?
Well, let's dive into that. First off, it's important to remember that used oil isn't just dirty sludge. It's a potent fuel packed with energy.
Right. It's essentially recycling in its most literal form, taking something considered waste and turning it into a valuable resource.
Exactly.
Okay, I like that. But how do we actually extract that energy and turn it into heat?
Just like with wood, we need to burn it. But burning used oil safely and efficiently requires a bit more finesse.
I can imagine. So, what are the key things to consider?
Well, first and foremost, we need to ensure a clean and complete burn to get the most heat and minimize those emissions.
Right. We want to make sure it burns properly. So, how do we achieve that?
It all comes down to the burner design. You need to preheat the oil to vaporize it before combustion, just like those rocket-like principles we discussed earlier.
Right. So, we're essentially burning the oil in its most efficient form.
Exactly. It's like fine-tuning an engine.
I like that analogy. But how do we actually do that? Preheating and vaporization.
That's where the burner design comes in. There are a few different types of used oil burners, but they usually involve heating the oil to a specific temperature, somewhere around 150 to 200 degrees Celsius.
Okay, so it needs to get pretty hot. How do we do that? Electric heating elements.
You could use electric heating elements or even utilize the heat from the combustion process itself.
Wait, we can use the heat from the burning oil to preheat the incoming oil. That's clever.
It is. It's a very efficient way to utilize the energy within the system. And once that oil is vaporized, it's mixed with air and ignited in a combustion chamber.
Okay, so I'm picturing a tank for the used oil, a pump to move it to the burner, and then a combustion chamber where it all comes together.
You're on the right track. But we also need to think about how to control that combustion process to ensure both efficiency and safety.
Safety first, for sure. What kind of safety features should we be thinking about?
Well, you need to make sure the oil is flowing at the right rate and that the temperature and pressure inside the system are within safe limits. This usually involves sensors, pressure relief valves, and automatic shutoff mechanisms.
So it's about redundancy and fail-safes to prevent any hazards.
Exactly. And it's important to remember that any fuel-burning system needs regular maintenance, whether it's wood, oil, or gas. You got to keep things running smoothly.
For sure, maintenance is key. Now, what about those byproducts of combustion? Soot and emissions. Are those a concern with used oil heating?
That's a good question. While modern used oil burners are designed to minimize soot, there will always be some residue. So regular cleaning is essential for both the burner and the chimney.
So it's like maintaining a wood stove, keep it clean and it'll run well.
Exactly. As for emissions, burning used oil does produce exhaust gases, just like any other combustion process. But with a well-maintained burner and proper ventilation, those emissions can be kept within safe limits.
So it's all about responsible operation.
Mm,
Okay, that makes sense. It seems like a viable option for home heating, especially if you're looking for a sustainable and potentially cost-effective alternative.
it can be, especially if you have access to that reliable source of used oil. And remember, you're basically getting free fuel.
That's a huge plus. All right, well, we've covered some pretty exciting ground here. We've talked about rocket stoves, the classic Vidrus, and even delved into the world of burning used oil. But now I want to revisit that futuristic idea of plasma heating.
Oh, yes. Plasma. It's definitely a fascinating concept.
It is. So I'm curious, how would a plasma heating system actually work in practice?
To understand plasma heating, we need to break it down. Remember, plasma is basically superheated matter, so hot that the atoms break down.
Right, like a mini lightning bolt.
Exactly. And to create that plasma, we apply a high voltage across a gas, like air.
Creating that electrical arc.
You got it. Just like in a welding torch.
Okay, I'm starting to picture it. But how do we use that arc for heating?
Well, remember that ChatGPT conversation? They talked about modifying a plasma cutter to create a continuous arc, and then using that arc to ignite and sustain combustion.
So instead of a traditional burner, we're using a plasma arc to superhit the fuel.
Exactly. And because plasma can get so incredibly hot, it can potentially burn almost anything.
Wow. So it's not just about efficiency, it's about versatility too. But I'm guessing there are some serious safety considerations with something that powerful.
Oh, absolutely. Working with plasma requires careful engineering and safety protocols. We're dealing with extreme temperatures and high voltages.
So while the concept of plasma heating is super intriguing, it sounds like it requires a high level of technical expertise.
It does. But the potential benefits are significant, especially when it comes to efficiency and fuel flexibility.
Okay, I'm definitely intrigued. We also touched on those MHD generators earlier. What are those and how do they fit into this conversation about plasma and energy?
MHD generators are a really interesting example of how we can directly convert heat energy into electricity. They work on the principle of electromagnetism.
Electromagnetism, can you break that down for me?
Sure. Basically, it means that moving charged particles through a magnetic field can create an electric current.
Okay, that's a bit technical for me. Can you explain it a bit more simply?
Imagine a stream of plasma, which, remember, is made up of charged particles flowing through a channel. Now, if you apply a strong magnetic field across that flow, it forces those particles to one side.
So we're separating the positive and negative charges in the plasma using a magnet.
Exactly. And that separation creates an electrical potential that we can then harness as electricity.
Wow, that sounds incredibly efficient. But you mentioned earlier that MHD generators are quite complex. What are some of the challenges?
One of the biggest challenges is that they require extremely high temperatures and strong magnetic fields to work effectively. That's a tough engineering problem.
Yeah, I can imagine. So while the concept is fascinating, it sounds like MHD generators are still a ways off from being practical.
They are, but the research is ongoing. Who knows, maybe one day we'll see MHD generators powering our homes.
That would be amazing. Now, you mentioned earlier that we could use plasma to burn a variety of fuels, even waste materials. What are the pros and cons of burning different fuel sources in a plasma system?
That's a great question. One of the biggest advantages of plasma gasification is that it can handle a wide range of fuels, even those that are difficult to burn using traditional methods.
So we could potentially burn things that would normally end up in a landfill.
Exactly. Turning waste into energy, the ultimate form of recycling.
That's a fantastic idea. But are there any drawbacks?
Well, one concern is harmful emissions. Different fuels produce different byproducts, and it's crucial to make sure those byproducts are managed responsibly.
So we need to be careful about what we're burning and how we're burning it.
Exactly. Another challenge is the energy balance. Some fuels require more energy to process than others. So it's about making sure you're actually gaining more energy than you're putting in.
Right, we don't want to end up using more energy than we're producing. It defeats the whole purpose.
Exactly. It's all about finding that sweet spot.
I agree. Now, remember how we talked about capturing the heat from a plasma system to generate electricity using a Stirling engine?
Yes, Stirling engines are really interesting.
They are. And I like that they're known for being pretty quiet. So it seemed like a good way to create a combined heating and power system.
It does. And one intriguing aspect is the potential for a closed-loop system.
A closed-loop system, what does that mean?
Imagine this. The heat from the plasma gasification process powers a Stirling engine, which generates electricity. The waste heat from the Stirling engine then preheats the incoming fuel.
So we're basically creating a self-sustaining energy loop.
Exactly. Minimizing waste and maximizing energy use.
Yes. That's a fantastic concept, but how practical is it?
Well, it's definitely a complex engineering challenge, but the potential rewards are huge.
This whole conversation about plasma, MHD generators, and closed loop systems has really blown my mind.
It's an exciting field, and it's constantly evolving. But remember, even those futuristic ideas are built upon the basic principles of efficient combustion and heat transfer.
Right, so it's about understanding the fundamentals and then applying them in new and innovative ways.
Exactly.
Okay, so while I might not be building a plasma power plant in my backyard anytime soon, I can definitely appreciate the ingenuity and innovation behind these concepts.
Absolutely. And who knows, maybe these ideas will inspire you to explore new ways to heat your own home.
That's a great point. This whole conversation has definitely sparked my curiosity, but now I'm wondering about the practical considerations of putting these ideas into practice.
That's a crucial question. Implementing any new heating system requires careful planning. Things like cost, materials, regulations, and safety all need to be considered.
Right, it's not just about the technology itself, it's about how it fits into our lives.
Exactly.
Okay, so while we've explored some pretty wild ideas, it all comes back to finding practical and sustainable ways to heat our homes.
Precisely. And the beauty is that there's no one-size-fits-all solution. The best heating system for you depends on your individual needs and priorities.
So it's all about finding the right balance.
Exactly. And that's where research, planning, and expert advice come in.
This has been an incredibly insightful conversation. I'm feeling inspired to do some more research and explore some of these ideas further, especially those related to using used oil for heat.
That's great. That's a really promising option.
It is. But before we wrap up, I'm curious about one more thing. We've talked a lot about the technical side of heating, but what about the environmental impact? What should we consider when evaluating the sustainability of different heating systems?
That's an essential question. And evaluating the environmental impact requires a holistic approach. It's not just about the fuel itself.
So what else should we be thinking about?
Well, you need to look at the entire life cycle of the system, from fuel extraction to emissions and even the disposal of any waste.
Right, it's about the big picture.
Exactly.
Yeah.
For example, even with a renewable fuel like wood, you need to consider how it's harvested and transported. Is it sustainably sourced?
That makes sense. So even with renewables, there can be hidden costs.
Absolutely. And then there's the issue of emissions. Even the cleanest burning fuels produce byproducts. So minimizing those emissions is key.
So it's about how we burn it, too.
Precisely. And finally, we need to think about the disposal of any waste products, like ash or soot.
Right, it's all connected.
It is. So it's a complex equation with many factors to consider. But I think the key is to strive for a balance.
A balance between efficiency, sustainability, and practicality.
You got it. And remember, finding the perfect heating system is an ongoing journey.
That's a good way to look at it.
As technology evolves and our understanding of environmental impacts deepens, we'll find new and better ways to heat our homes.
That's an inspiring thought. So it's not about finding the ultimate solution. It's about continually striving for improvement.
Exactly. And that's what makes this conversation so exciting. It's about embracing innovation and exploring new possibilities.
This has been an incredibly thought-provoking deep dive.
I'm glad you enjoyed it.
I'm feeling inspired to do more research, especially on those used oil systems.
That's great. It's a really fascinating topic.
It is. And before we wrap up, I wanted to mention one more thing from that ChatGPT conversation. The idea of combining different heating technologies to create a hybrid system.
Hybrid systems are a really interesting approach.
Yeah, they seem like a good way to combine the strengths of each technology.
Exactly. You could pair a high-efficiency wood stove with a solar thermal setup, for example.
That's a great idea. So you get renewable energy from the solar and reliable heat from the wood stove when you need it.
Exactly. It's about creating a more resilient system.
I like that. So it's about picking and choosing the best of each technology to meet your needs.
Exactly. And as we move towards a more decentralized energy future, these hybrid systems are going to become even more appealing.
It makes sense. It's like a bridge to a more sustainable future.
Exactly.
This has been an incredibly insightful and eye-opening deep dive. I'm feeling inspired and ready to start exploring these ideas further.
That's fantastic. And remember, that conversation between the user and ChatGPT is a great starting point for your research. It's a good reminder that sometimes unconventional sources can lead to new discoveries.
Absolutely. And it highlights the potential of AI as a learning tool.
It really does.
Well, I think that wraps up our deep dive into the world of alternative heating and energy.
This is a great conversation.
It was. Any final thoughts before we sign off?
I think the biggest takeaway is that there's no one-size-fits-all solution when it comes to heating. The best approach for you will depend on your individual circumstances.
That's great advice. So do your research, consider your options, and find what works best for you.
Exactly. And don't be afraid to think outside the box and explore new possibilities.
Well said. All right, that's it for today's show. Thanks for joining us.
Thanks for having me. It was a great discussion. So, where were we? Ah, yes, used oil. We were about to break down the nuts and bolts of using it for heat.
Exactly. It's like this whole other world of heating that most people don't even know about.
It is, and it's a really fascinating one. You know, a lot of folks think of used oil as just, well, waste. But it's actually a potent fuel source. It's packed with energy, just waiting to be harnessed.
That's what's so cool about it, right? We're talking about recycling in the most literal sense.
Yeah,
Taking something that would otherwise be discarded and turning it into something useful.
precisely. It's a beautiful example of circularity and resourcefulness.
Okay, so we've established that used oil has energy potential. But how do we actually extract that energy and turn it into heat for our homes?
Good question. Well, just like with any other fuel, we need to burn it. But burning used oil efficiently and safely, that's where the art comes in.
I can imagine it can't be as simple as just throwing it on a fire, right?
Definitely not.
Hmm.
It requires a bit more finesse than that. We need to think about things like preheating the oil to vaporize it before combustion. Remember those rocket-like principles we talked about earlier?
Oh, right. Controlling the burn for maximum efficiency.
Exactly. And that's particularly important with used oil because we want to ensure a clean and complete burn. That way, we get the most heat output and minimize those pesky emissions.
Makes sense. So how do we go about preheating and vaporizing the oil? Do we use something like electric heating elements?
Electric heating elements are one option, but we can actually get even more clever. Some systems utilize the heat from the combustion process itself to preheat the incoming oil.
Wait, so we can use the heat from the burning oil to preheat more oil?
You got it. It's a very elegant way to make the system more efficient, wouldn't you say?
Absolutely. It's like a self-sustaining loop.
It is. It's all about harnessing that energy and using it wisely. Once the oil reaches the right temperature and vaporizes, it mixes with air and ignites in the combustion chamber.
Okay, so I'm picturing a system with a tank to store the used oil, a pump to move it to the burner, and then that combustion chamber where the magic happens. Am I on the right track?
You're getting the hang of it. But we also need to consider how we're going to control that combustion process. Remember, safety is paramount. We don't want any runaway reactions or unexpected surprises.
Right. We need to be smart about this. So what kind of safety features are we talking about?
We need to make sure the oil is flowing at the right rate, not too fast, not too slow, and we need to make sure the temperature and pressure inside the system stay within safe limits.
So it's about having those checks and balances in place.
Exactly. Sensors, pressure relief valves, automatic shutoff mechanisms, these are all crucial components of a safe and reliable used oil heating system.
Okay, so it's not just about building a burner. It's about building a safe and controlled system.
Precisely. And just like with any fuel burning system, whether it's wood, oil, or gas, regular maintenance is key. Inspections, cleaning, making sure everything is in good working order, it all contributes to a safe and efficient operation.
Regular maintenance, got it. It's like taking care of your car, right? You got to keep things running smoothly.
Exactly. Now, what about those byproducts of combustion? Soot, emissions, are those a concern with used oil heating?
That's a good question. I was wondering about that too.
It's definitely something to be aware of. Now, modern used oil burners are designed to minimize soot production, but there will always be some residue.
So it's similar to a wood stove in that way. You need to clean it out regularly.
Exactly.
Yeah.
Regular cleaning of both the burner and the chimney is essential to keep things running smoothly and safely.
Got it. Soot and ash. Got to keep those in check. What about the emissions, though? I know burning oil can release harmful gases into the atmosphere.
That's true. But the good news is that with a well-maintained burner and proper ventilation, those emissions can be kept within safe limits. It's all about responsible operation and minimizing our impact on the environment.
So it's not just about the fuel source. It's about the whole system and how it's managed.
You've got it. It's about taking a holistic view, considering all the factors, and making informed decisions.
Okay, so it sounds like used oil heating has A lot of potential, but it also requires careful planning and attention to safety.
That's a fair assessment. But for those seeking a sustainable and potentially cost-effective alternative to traditional fuels, it's definitely worth considering.
Especially if you have access to a good source of used oil.
Exactly. It's like getting free fuel. So, are you ready to dive back into the world of high-tech heating? Let's revisit that plasma heating idea.
Oh yeah, plasma. It still feels like something straight out of Star Trek to me.
It does have a certain futuristic ring to it, doesn't it?
Yeah.
But as we discussed earlier, the potential of plasma for heating and even electricity generation is very real.
Okay, so remind me again, how would a plasma heating system actually work?
Well, remember, plasma is essentially superheated matter, so hot that the atoms break down into charged particles.
Right, like a miniature lightning bolt.
Exactly. And to create that plasma, we apply a high voltage across a gas, like air.
Which creates that electrical arc.
You got it. It's the same principle used in welding torches and plasma cutters.
Okay, I'm starting to get the picture again. But how do we actually harness that arc for heating?
Well, the ChatGPT conversation talked about modifying a standard plasma cutter to create a continuous plasma arc, and then using that arc to ignite and sustain the combustion of a fuel source, just like we discussed with used oil.
So instead of a traditional burner, we're using this incredibly hot plasma arc to superheat the fuel.
Precisely, and because plasma can reach such insanely high temperatures, thousands of degrees Celsius, it opens up a whole new world of possibilities. We could potentially burn just about anything.
Wow, even things that are difficult to burn with conventional methods.
Exactly. That's one of the biggest advantages of plasma heating, its versatility. It's not just about efficiency, it's about being able to utilize a wider range of fuel sources.
That's amazing. But I have to imagine there are some serious safety concerns when dealing with something that powerful.
You're absolutely right. Working with plasma requires a whole different level of expertise and safety protocols. We're talking about extreme temperatures and high voltages, so proper containment, shielding, and control systems are absolutely critical.
So while the concept is incredibly cool, it sounds like it's not something you'd want to try at home.
It's definitely not a DIY project. It requires specialized knowledge and equipment. But the potential benefits, especially in terms of efficiency and fuel flexibility, make it a fascinating area of research.
Okay, I'm definitely intrigued. Earlier, we also briefly mentioned MHD generators. Can you remind me what those are and how they fit into this conversation about plasma and energy?
MHD generators are a fascinating example of how we can directly convert heat energy into electricity. And they rely on the principle of electromagnetism.
Electromagnetism, right. That's where things get a little fuzzy for me. Can you break it down in simpler terms?
Absolutely. Think of it this way. Electromagnetism is the interplay between electricity and magnetism. And one of the key principles is that moving charged particles through a magnetic field can induce an electrical current.
Okay, I think I'm following so far, but how does that apply to an MHD generator?
Well, imagine we have a stream of plasma, which we know is made up of those charged particles, flowing through a channel. Now, if we apply a strong magnetic field perpendicular to that flow, it creates a force that pushes those charged particles to one side of the channel.
So we're essentially separating the positive and negative charges within the plasma, like using a magnet to sort them out.
That's a great analogy. And that separation of charges creates an electrical potential difference, which we can then harness as electricity. It's a very elegant and efficient way to generate power directly from heat without needing any moving parts like turbines or generator.
Wow. No moving parts. That sounds incredibly efficient and potentially very reliable.
It does, doesn't it?
Hmm.
But there's a catch. MHD generators require extremely high temperatures and strong magnetic fields to operate effectively. And that presents some significant engineering hurdles, especially when you consider the materials needed to withstand those extreme conditions.
Right. We're talking temperatures that can melt most metals and incredibly powerful magnets. So while it's a fascinating concept, it sounds like MHD generators are still a ways off from being practical for everyday applications.
They are. But the research is ongoing. Who knows, maybe someday we'll see MHD generators powering our homes and communities. Wouldn't that be amazing?
It would be a game changer. Now, you mentioned earlier that we could potentially use plasma to burn a wide range of fuels, even waste materials. That sounds incredible. But are there any downsides to burning different types of fuels in a plasma-based system? What are the pros and cons?
That's a great question. It's important to look at the big picture when considering different fuel sources. One of the biggest advantages of plasma gasification is its ability to handle a wide range of fuels. even those that are difficult or impossible to burn using traditional methods. This opens up the possibility of utilizing waste materials that would otherwise end up in landfills, turning them into a valuable source of energy.
It's like the ultimate form of recycling, right? Turning trash into treasure.
Exactly. It's a fantastic concept with huge potential for sustainability. But of course, we need to be realistic. There are also challenges.
What kind of challenges?
Well, one concern is the potential for harmful emissions. Different fuels will produce different byproducts when burned, and it's crucial to ensure that those byproducts are either captured and treated or released in a way that minimizes their impact on the environment. We don't want to solve one problem by creating another.
Right, it's about responsible innovation.
Exactly. We need to be smart about it. And another challenge is the energy balance. Some fuels require more energy to process and gasify than others. So it's important to consider the overall energy efficiency of the system. We want to make sure we're actually gaining more energy than we're investing.
That makes a lot of sense. We don't want to end up using more energy than we're producing.
Exactly. It's all about finding that sweet spot where we're maximizing energy output while minimizing our environmental impact.
Okay, so there's a lot to consider. Now, earlier we talked about the idea of using a Stirling engine to capture the heat from a plasma-based system and generate electricity. That whole closed-loop system concept was really intriguing. Can you elaborate on that a bit more?
Absolutely. It's a really fascinating concept. Remember, a closed-loop system is all about minimizing waste and maximizing energy utilization. Imagine this. The heat from the plasma gasification process is used to power a Stirling engine, which generates electricity. But here's the clever part. The waste heat from the Stirling engine is then captured and used to preheat the incoming fuel, further enhancing the overall efficiency of the system. It's a beautiful example of circularity and resourcefulness, wouldn't you say?
It's like a perpetual motion machine, but with energy.
It's a bit like that. Of course, we can never achieve perfect efficiency, but the concept of a closed-loop system is all about striving for that ideal. We want to minimize losses and get the most out of every bit of energy we put into the system.
Okay, so it's about squeezing every last drop of energy out of the system. But how practical is it to actually build and operate a closed-loop system like that? What are some of the design and engineering considerations?
Well, it's definitely a complex undertaking. There are many factors to consider, including the choice of materials, the design of the plasma chamber, the integration of the Stirling engine, and the overall control systems. It's a challenging engineering puzzle, but the potential rewards in terms of efficiency and sustainability are significant.
It sounds like a fascinating challenge for engineers and innovators.
It is. And remember, even seemingly futuristic ideas like these are built upon those fundamental principles of efficient combustion, heat transfer, and energy conversion.
Right, so it's about understanding the basics and then applying them in new and creative ways.
Exactly.
Okay, well, this entire conversation has really opened my eyes to the incredible possibilities of energy technology. While I might not be building a plasma power plant or an MHD generator in my backyard anytime soon, I can definitely appreciate the ingenuity and innovation behind these concepts.
And who knows, maybe these ideas will inspire you to explore new ways to heat your own home. Maybe you'll be the one to come up with the next breakthrough in heating technology.
Maybe. It's definitely given me a lot to think about. But for now, I think I'm still leaning towards exploring those more practical options, like used oil heating. It seems like a good balance of sustainability, efficiency, and feasibility.
That's a great choice. Used oil heating is a fantastic option, and it's definitely more accessible than some of these other technologies we've been discussing. But regardless of which path you choose, remember that it's all about finding the right solution for your individual needs and circumstances. There's no one-size-fits-all approach to heating.
That's good advice. So, as we wrap up this part of our conversation, do you have any final thoughts or key takeaways that you'd like to leave our listeners with?
I think the biggest takeaway is this. Don't be afraid to challenge the status quo when it comes to heating your home. There are so many innovative and sustainable options out there, and with a little research and an open mind, you can find a solution that's both comfortable and environmentally responsible.
That's great advice. And it's a reminder that we all have a role to play in shaping a more sustainable future, even in something as seemingly mundane as heating our homes. So whether you're considering a rocket stove, a used oil burner, a hybrid system, or even those futuristic plasma-based technologies, remember that the future of heating is full of possibilities.
Absolutely. All it takes is a bit of curiosity and a willingness to explore.
Well said. Now, let's shift gears a bit and talk about the environmental impact of all these different heating systems. I know we've touched on it here and there, but I think it deserves a deeper dive. What are some of the key things to consider when evaluating the sustainability of different heating options?
That's an essential question, and it's one that often gets overlooked. Evaluating the environmental impact of any heating system requires a more holistic approach. We can't just focus on the fuel source itself. We need to consider the entire life cycle of the system.
Okay, so what does that mean exactly? What are some of the key factors we should be considering?
Well, for starters, we need to think about the extraction and production of the fuel itself.
Oh.
Where does it come from? How is it obtained? What are the environmental impacts associated with those processes?
Right, it's about understanding the origins of the fuel, not just how we burn it.
Exactly. For example, even if a fuel source is renewable, like wood, we need to consider how it's harvested and transported. Is it sustainably sourced? Are we replenishing what we're taking? And what are the emissions associated with getting that wood from the forest to our homes?
That makes sense. So even with renewable fuels, there can be hidden environmental costs.
Absolutely. And then there's the combustion process itself. Even the cleanest burning fuels will produce some byproducts. So minimizing those emissions through efficient burner design and proper ventilation is crucial.
So it's not just about what we burn, it's also about how we burn it.
You've got it. It's about optimizing the combustion process to minimize our environmental footprint.
Makes sense. So we've got fuel extraction and production, combustion emissions, what else?
Ah, yes. We can't forget about waste disposal. What happens to the byproducts of combustion? Ash from wood burning, soot from oil burning. These are all things we need to consider. Are they being disposed of responsibly? Can they be recycled or repurposed?
Right, it's about closing the loop, so to speak, thinking about the entire life cycle of the fuel and the system.
Precisely. It's about taking a systems thinking approach.
Okay, so it's a complex equation with a lot of variables, but it sounds like the key is to strive for that balance between efficiency, sustainability, and practicality.
You've hit the nail on the head. And remember, the quest for the perfect heating system is an ongoing journey. As technology evolves and our understanding of environmental impacts deepens, we'll continue to find new and better ways to keep our homes warm while minimizing our impact on the planet.
That's an inspiring thought. So it's not about finding the ultimate solution, it's about continually striving for improvement.
Exactly. And that's what makes this whole conversation so exciting. It's about embracing innovation, challenging assumptions, and exploring new possibilities.
This has been an incredibly thought-provoking conversation. I'm feeling inspired to do some more research and explore some of these ideas further, especially that used oil heating system. It's really caught my attention.
That's fantastic. I'm
Yeah.
glad you're feeling inspired. And remember, the source material for this deep dive, that conversation between a user and ChatGPT, is a great place to start. It's a great reminder that we can find inspiration and knowledge in the most unexpected places.
Absolutely. It really highlights the potential of AI as a learning tool.
It does.
All right, well, before we wrap up this deep dive, I wanted to touch on one last thing that came up in the ChatGPT conversation, the idea of combining different heating technologies into a hybrid system. What are your thoughts on that approach?
Hybrid heating systems are a really fascinating concept, and they offer a lot of potential. They allow us to take advantage of the unique strengths of different technologies while mitigating their weaknesses. It's about creating a system that is more adaptable, more resilient, and ultimately more sustainable.
So it's about picking and choosing the best of each technology.
Exactly. It's like building a custom heating solution tailored to your specific needs and circumstances. For example, you could combine a high-efficiency wood stove with a solar thermal setup. That way, you'd benefit from renewable energy when the sun is shining and have the reliable warmth of wood heat as a backup.
That's a great example. It's about creating a more balanced and integrated approach to heating.
Precisely. And as we transition to a more decentralized and renewable energy future, these hybrid systems will become even more appealing. They offer a way to move away from fossil fuels while ensuring a comfortable and reliable source of heat.
So it's like a bridge to a more sustainable future.
Exactly. Of course, whenever you're combining different technologies, it's crucial to consider the overall energy balance of the system. You want to make sure you're gaining more energy than you're investing.
Right, it all comes back to that efficiency equation.
It does. But hybrid systems offer a lot of flexibility and potential, especially as we explore new and innovative ways to heat our homes.
This has been an incredibly insightful and eye-opening deep dive into the world of heating and energy. I've learned so much.
It's been my pleasure. I'm glad you found it valuable.
I'm feeling inspired and ready to start putting some of these ideas into practice. Maybe I'll even give that used oil heating system a try.
That's fantastic. Remember, the journey of discovery is just as rewarding as the destination.
Well said. Well, I think that wraps up our deep dive into the world of alternative heating and energy. It's been an incredible journey.
It certainly has.
Any final thoughts before we sign off?
I think the biggest takeaway is this. Don't be afraid to challenge the status quo when it comes to heating your home. There are so many innovative and sustainable options out there. With a little research, an open mind, and a willingness to explore, you can find a solution that's both comfortable and environmentally responsible.
That's great advice. And it's a reminder that we all have a role to play in creating a more sustainable future, even in something as seemingly simple as heating our homes. So, to all our listeners out there, whether you're considering a rocket stove, a used oil burner, a hybrid system, or even those futuristic plasma-based technologies, keep exploring, keep innovating, and keep those home fires burning brightly and sustainably.
Here, here. It's really amazing how much ingenuity goes into these different approaches to heating.
It is. It makes you realize that we have so many options beyond those conventional systems we're used to.
And with the growing concerns about climate change and resource depletion, it's more important than ever to explore those alternative and sustainable heating options.
Absolutely. Now, before we get too far ahead of ourselves, I want to circle back to something we've talked about earlier, the idea of combining different technologies into those hybrid heating systems. Seems like a really smart way to take advantage of each approach, right?
It's a strategy that's gaining traction as people look for more resilient and flexible ways to heat their homes.
Yeah, I can definitely see the appeal. So, for example, you could pair a high-efficiency wood stove with a solar thermal setup.
Exactly. You get the cozy warmth of wood heat, but you're also tapping into that renewable solar energy whenever it's available. It's about creating a system that's greater than the sum of its parts.
So it's not just about choosing one technology over another. It's about finding the right combination that works for you.
Exactly. And as we move towards a more decentralized energy future, those hybrid systems will become even more appealing.
Right. It's like a bridge to a more sustainable future. But with so many possibilities, how do we even begin to evaluate what's best for us?
That's where careful research and planning are essential. It's about understanding your heating needs, your budget, what fuel sources are available in your area, and your priorities when it comes to things like sustainability and efficiency. It's a personal decision.
It is. There's no one-size-fits-all solution.
Exactly. What works for one person might not work for another. And that's where talking to experts in the field can be really valuable.
So it's about doing your homework and seeking out expert advice.
Precisely. And remember, the journey of discovery is just as important as the destination.
That's a great point. So as we wrap up this deep dive, what are some key takeaways or parting thoughts that you'd like to leave our listeners with?
I think the most important message is, don't be afraid to challenge the status quo when it comes to heating your home.
I love that. Don't be afraid to think outside the box.
Exactly. There are so many innovative and sustainable options out there, and with a little research and an open mind, you can find a system that works for you and the planet.
That's inspiring advice. It's a reminder that we all have a role to play in creating a more sustainable future, even in something as simple as heating our homes. So to all our listeners out there, keep exploring, keep innovating, and keep those home fires burning brightly and sustainably.
Well said. It's been a pleasure joining you on this deep dive.
The pleasure was all mine. And to our listeners, thanks for joining us on this journey into the world of alternative heating and energy. We'll see you next time.